Hello, my name is Anish, and today I'm going to be teaching trigonometry in the easiest way possible with the easiest usage of English. So, we're just going to dive in. So, what I really want to start with is really the basics of sine, cosine, and tangent. Now you might be intimidated by these sine, cosine, and tangent words that I just drew here, but really anyone, even primary school kids, middle school kids, can definitely understand this. So we all know what a triangle is, right? Triangles can be like this. This is an equilateral or isosceles. Let's just imagine it's an isosceles triangle. And we can have right triangles. This is a right triangle because it has a 90 degrees. And just if you don't know, right triangles have 90 degrees. So what that means is that the 90 degrees is when you have two lines that are perpendicular. So you have perpendicular is just another way of saying, hey, you have one line and you have another line and they intersect at a 90-degree angle. And you can approximate and you can think of something as a 90-degree angle when you have one line going down here and another line going horizontally intersecting it. And you have just an L shape. So whenever you find like an L shape, obviously double check yourself, but it usually would be a 90-degree angle. And then you would also have acute triangles, which are like equilateral or isosceles triangles, like this one. And then you would also have obtuse angle triangles. And I know our topic today is about sine, cosine, and tangent, but just a bit of a review because you would have to know the differences. Isosceles triangles. Isosceles triangles are usually acute. They're usually acute angles, meaning that they're less than 90 degrees. What is 90 degrees? It is that L formation that I was talking about earlier. So whenever somebody uses the word acute, A-C-U-T-E, like over here, they are referring to an angle that is less than 90 degrees. But once again, degrees cannot be in the negative. So less than 90 degrees, greater than or equal to 0 degrees. And then over here, we have a right angle triangle. Right angles it's just a right angle. It is just a right angle over here. If you can see, it's a right angle, and this is equal to 90 degrees. So when someone tells you, about some kind of problem that refers to a right angled triangle, just be aware that it's a triangle with only one 90-degree angle. And then over here we have an obtuse angle triangle. What obtuse means is that it is greater than 90, but it is also less than 180. Triangles, they all sum up to 180 degrees. So the obtuse angle would have to be less than the 180 degrees, because if all of them sum total to 180 degrees, you can't have an angle that's more than that, because that just would not work in triangles, in the law of triangles. So greater than 90, less than 180, that would be the obtuse. And now that we know that those are basically the basics of triangles, there's much more to learn about, but being able to classify that is definitely a must in trigonometry. Now, what you would do is that for trigonometry is basically referring to right triangles. And what are right triangles? Right triangles, like I said, are triangles that have a 90-degree angle. And then now we're going to look at sine, cosine, and tangent. Now, please do not be intimidated by this, because it is really just It is really just sine is cosine and tangent. So in order to pronounce sine, it's pronounced like S-I-N-E, sine, but this is what you would write for sine. And then for cosine, you might read it as cos, but it is actually pronounced as cosine. Cosine, like this. And then tangent, you would read it as tan if you would not know what tangent is, but it is actually pronounced as tangent. And now that we do know that, we are going to try to learn the basics of trigonometry here. And once again, do not be intimidated. It's never too early to learn about trigonometry, even primary school or middle school. It's just a nice extra knowledge to know, and to retain that knowledge is very good once you get into your high school years, if you have not already. So you have our right triangle. Let's just draw a big right triangle here. And then you have our 90-degree angle. Now, what I do want to do is that I do want to symbolize a 30, 60, 90 triangles. This would be 30, this would be 60, and this would be 90. So it is 30, 60, 90. 30, 60, 90 triangles are a common, angle pattern for triangles. As you know that triangles do add up to the 180. 30 plus 60 is 90, plus 90 is 180. So now, referring back to our sine, cosine, and tangent, what does this mean? Well, we do know that this is the hypotenuse. And this is a leg. Think about it as these are basically the legs that lift up the hypotenuse. And to write it down, this is how you would pronounce it. This is how almost you would pronounce it. It's like high, pot, and then enuse. But it is spelled Hypotenuse. And you would, for sine, cosine, and tangent, for sine, it is going to be opposite over the hypotenuse. So what does that really mean? You might just be wondering, hey, what does this mean, opposite over hypotenuse? Never heard of it. Well, let's just say, for example's sake, you want to have the sine of 60 degrees. We have a 30, we have a 60, and we have a 90. But we want this guy over here. We want to find the sine of 60. What do? As sine is the opposite over hypotenuse, you would find the angle that they are referring to. So if they say sine of 60, look to the side opposite to that. This is an angle over here, but look to the side opposite to that. That is this leg. So you would put this leg, that leg, over the hypotenuse. And then let's say if you were to do sine 30, you would always look at the angle opposite to it. Hey, 30, what's up 30? But we really want this. We would use that leg over the hypotenuse. And that is really the basics of sine. And then now moving on to our friend here, cosine. Cosine is actually, there really isn't a varying difficulty, a harder method here, like a harder sine, cosine, or tangent, like the method in solving these kinds of problems. But sine, cosine, right? So let me just draw a new right triangle, just to make it very orderly and clean. And this is our leg, and this is our leg, and this is our hypotenuse, and then this is our 30. This is our 60, and then this is by default the 90 as the right triangle, the right angle. So cosine is equal to adjacent over hypotenuse. We know what hypotenuse is. We all know it's this bad boy here. But what is adjacent? Adjacent is another word for next to. So if you want to find the cosine of 60, we have this guy, right? You know, for sine, you find the opposite, so it would be this leg. But for cosine, you're finding the leg next to. And because sine and cosine are always leg over hypotenuse, but you're always wondering, which leg is it? So if you're finding the cosine of 60, you're finding the leg. You're finding the leg that is adjacent to it. And in this case, the leg adjacent to this 60 is this one. So it is going to be using that leg. It is going to be leg over hypotenuse. And it might be a bit messy, but let me just draw one more as an example here. I know it is kind of messy. I want to make it as clean as possible for you guys. That's a 30, and this is the 60. This is the hypotenuse. This is the leg, and this is the leg. So now we want to find the cosine of 30. And just be mindful, it does not have to always be sine or cosine of 30 is 60. These can be varying degrees. This is just a conventional form what you would see on some problems. So if you want to find the cosine of, not 60, but the cosine of 30. The cosine of 30 is going to be, so you would find the leg adjacent, and then you would find this leg to be the leg adjacent to this 30 degrees. So you would put this leg as that leg, as in the numerator, over the hypotenuse. You always put it over the hypotenuse here, as this leg is the leg next to the degree. That's how you find the cosine. Next is tangent. Tangent is a bit different, as you will see. You have your right triangle. You have your 30 degrees. You have your 60 degrees, and you have your 90 degrees, and then you have your leg over here. You have your leg, and then you have your hypotenuse. I will just extend it because this is the last one. So what is tangent? Tangent is opposite. I'm going to write it down over adjacent. And please don't be tricked when I do put ADJ, because that is adjacent and HYP is hypotenuse, just to make that clear, to avoid any kind of confusion. So opposite over adjacent, what does this mean? We all know that for sine 60, for example, right? Sine 60 would be this leg over hypotenuse. Cosine 60 would be this leg over hypotenuse, because this is the adjacent one for cosine, and this is the opposite one for sine. Now, we want to do tangent, opposite over adjacent. And then, try to solve this yourself with the information you know about sine and cosine for tangent, but we will work it out now. So let's just find the tangent of 30. And once again, just to go over this again, this does not necessarily have to be 30 or 60 in these two spots. Now, it does have to have a right angle, or 90 degrees, but for the other two corners, it does not have to be 30 or 60. This is just the conventional 30, 60, 90 triangle that we will just use as an example. So we want to find the tangent of 30. 30 is over here, right? 30 is over here. You want to find the one opposite. 30 is looking across the street. So another way you can find opposites is kind of looking across the street from the degree. So you start at the degree that's kind of your house, and you look across the street to your neighbor's house, and that's going to be the opposite. So opposite over adjacent, if you want to find tan 30, would be this leg, and then you want to find the adjacent one, 230. Now, just notice that you're finding the opposite one to the degree that you are putting here, and you're in the adjacent one. So the adjacent one to 30 is, once again, adjacent means next to. You want to find the leg next to the degree we're talking about. We're not talking about hypotenuse this time. So the leg next to 30 is going to be this leg. So it is going to be this leg over this leg as the tangent. It is the opposite to this angle, the opposite side to that angle over the adjacent side to this angle. So that is really the basics of trigonometry for sine, cosine, and tangent. Now, I know this was designed specifically for people who do not have too much knowledge in the trigonometry area, and yeah, trigonometry is very hard, but I hope that this kind of alleviated some of the intimidation that you might have felt when you first heard of the term trigonometry. But yeah, the next few videos I will be talking about the Pythagorean theorem, and though most of you who already know trigonometry would say, hey, why didn't you teach Pythagorean theorem first? Let me just say, I just wanted to teach a simple way of just doing advanced math without too many other practices involved. But in the next videos, I will involve the Pythagorean theorem and kind of show you and revisit it. It's the Pythagorean theorem uses the right angle triangle. But I hope you really learned about sine, cosine, and tangent. And just before we end the video, I'm just going to go over each piece. Just put the camera over it so you can just look at the work and get a refresher, and maybe rewind if you are having doubts. So over here, and then over here. Thank you guys for watching. I will surely release more videos about any type of math, algebra, trigonometry, pre-algebra, geometry. Just leave it in the comments below. I really appreciate any feedback on this video, as this is my first video. And I am definitely open to any considerations of like new videos. If you guys want me to teach algebra, then I'm more than happy to teach algebra, but just don't forget to be specific in what units you would want me to teach. But thank you guys very much. This is trigonometry for primary school students in the simplest way possible. I hope you guys enjoyed this video, and see you guys next time.